Hey, welcome to 2.1 Exponents. First thing I would like you to write down is everything in this green box. What is written here, write down only what you need for this section. Okay, you decide what you need to write down. You can abbreviate as needed, but definitely copy all this down. So, what is a power? Well, a power, like 5 to the third power, is made up of a base number, which is the 5, and the exponent, which is the 3. The whole thing put together is a power. When you take apart that power, it has 3 factors because the exponent tells us how many factors it is. And those 3 factors is the base number, 5 times 5 times 5, and you can multiply it out to 125. What we have here is just a reminder that if you have 8 to the first power, it just means 8. And we would just say 8 to the first power or 8. If you have 6 to the second power, and I'm just using these base numbers as examples, it would be 6 times 6, which is 36. And we could say it as 6 to the second power, but you could also just say 6 squared. So if you're going to just abbreviate your notes, maybe remind yourself that to the second power means squared. 4 to the third power is 4 times 4 times 4, which is 64. And 4 to the third power again. But there's another way of saying to the third power, and that is cubed. After that, anything raised to the next power is just going to be that power. So 2 to the fourth power means 2 to the fourth, whatever. To the fifth, you just write to the fifth. And there's no other special words. So write down what you need here. We have 2 to the fifth power, 2 to the fourth, 2 to the third, 2 to the second, 2 to the first. Cool thing about mathematics is it often works in a pattern. So 2 to the fifth is 2 times 2 times 2 times 2 times 2, which equals 32. 2 to the fourth is 2 times 2 times 2 times 2, which is 16. So on and so forth is 8, then 4, then 2. So the question is, what's the pattern? What's going on? And as you can look at 32, 16, 8, 4, 2, what's going on? Well, they're becoming half of it. What's another way of saying half of it? Divided by 2. Or another way of saying divide by 2, because that is what's happening, is 32 divided by 2 equals 16. You could say it's also multiplying by a half. So what's half of 16? 8. What's half of 8? Right? Is 4. What is half of 4? Or 4 times a half is 2. So then the question is, well, wait a minute. What happens when we get down to 2 to the 0 power? Well, if we follow this pattern and you have 2 times a half, what is 2 times a half? What's half of 2? You are correct. It is a 1. So you're telling me that 2 to the 0 power is equal to 1? Yes, I am. One of the other ways to think of it is you can have a secret agent number 1 in all of these. And so when I'm multiplying by 1 and then however many factors of 2 there are, when it's 2 to the 0, it's like 1 times no factors of 2. If we were to continue this pattern, the question would be, well, then what happens when it's a negative number? Negative exponent. Does the number become negative? Well, what happens when I take 1 and I multiply by a half? Does it become a negative? No. 1 times a half is a half. So I basically have 1 times like 1 over 2. And if I was to continue this pattern, what's half of a half? Half of a half is actually 1/4. So it's kind of like 1 times 1 over 2 times 2. So what's going to happen again? I have 1 over 2 times 2. So this is probably going to be 1 over 2 times 2 times 2. Well, what's half of a fourth? An eighth. So there's a couple cool things you'll see with the pattern that goes into the negatives, and one is that they are reciprocals of each other. So this is actually the same as 1 over 2 to the third. So 2 to the negative third is actually equal to 1 over 2 to the third. We'll get more into that later. If you follow the pattern once again, 10 to the third is 1,000, 10 to the second is 100, 10 to the first is just 10. Again, we are dividing by 10, or multiplying by 1/10. So we divide by 10, and then what happens when we divide 10 by 10? We get 1. So what happens when we have 10 to the 0 power? Well, it just equals 1. So we got to write down our rule. Rule: for every number a, and a cannot equal 0 because you don't want to have a base number of 0. But for every number a, if you have an exponent of 0, this is equal to 1.
Don't forget to write down your rule.
All right, let's practice some problems. We have 8 to the third times 8 to the second, which is 8 times 8 times 8 times 8 times 8. What's a shortcut? What's a short way of writing this? Well, I have 8 times 8 times 8 times 8 times 8. How many factors of 8 do I have? 5. Great. So this should be shortcut to 8 to the 5th. All right. 12 to the 4th times 12. I multiply it out. How many factors of 12 do I have? 5. So couldn't I just shortcut this and say it's 12 to the 5th? Well, wait a minute. Let's start thinking about a rule that could be happening here. 8 to the 3rd times 8 to the 2nd equals 8 to the 5th. 12 to the 4th times 12. Well, couldn't we call this 12 to the 1st equals 12 to the 5th? If I expand this one out, well, what is this going to be? Well, yeah, the 2 and the 5 makes it 7 factors. So I have 3 to the 7th power. So the rule for every number a, as long as a does not equal 0 again, and all whole numbers m and n, we have a to the m power times a to the n power will equal a. And what do we do with the exponents? We add them, m plus n. Hey Gabe, what do you think they should do with this rule?
They should always write down their rule because it will make them smarter.
Yeah.
Evaluate 2 to the 3rd times 5 to the 2nd. Let's expand it and see what we're talking about. We're talking about 2 times 2 times 2 times 5 times 5. Well, they do not have the same base, so I cannot just add the exponents. So what is 2 times 2 times 2? That is 8. What is 5 times 5? That is 25. And 8 times 25 makes 200. 200. Joseph, put away. Number 2, express 81 as a power of 3. So it's saying how can you write 81 with 3 as your power? So what's 3 times 3? 9 times 3, 27 times 3, 81. Excellent. So this is the same as 3 to the 4th power, and that would be how you would express 81 as a power of 3. Number 3, 7 to the 3rd. I can write it out. 7 times 7 times 7 times 7 to the 0. So how many 7s do I put? Well, I put any. In fact, what is 7 to the 0 power? What is any number raised to the 0 power? It is a 1. So all I'm actually trying to figure out here is what is 7 to the 3rd. If it says to leave it in exponent form, you can just leave it as 7 to the 3rd.
Excellent. Number 4, evaluate if n equals 3. So what's basically 3 squared? Don't forget when you enter in a value for the variable, please put it in a parenthesis so you know what is actually, what's the value of the variable and what is being raised to the exponent. So this means 3 to the 2nd, 3 times 3, which is 9.
Excellent. Number 6, 4n to the 2nd power. What's being raised to the 2nd power? All of 4n. Whereas in this one, what was being raised to the 2nd power? Just the n. Okay, so the parentheses are really, really important. So in this one, we have 4 times n, which is 3. And this is all being raised to the 2nd power. So what that means is it's 4 times 3, which is 12. And 12 is being raised to the 2nd power. 12 times 12 is?
124.
Close, 144. Excellent.
You rushed me.
I know. Surprise. All right, 3n to the 3rd over 12n to the 2nd. This means we have 3 times n is 3 to the 3rd power over 12 times 3 to the 2nd power. You know what? I could solve this, but this is a lot of work. So what I'm going to do is I'm actually going to expand it and think about what this means. This top one is 3 times 3 to the 3rd is 3 times 3 times 3. And the bottom number is 12 times 3 times 3. Is there anything I can simplify out? Yes, Gabe?
The 2 3s?
Yes, 3 goes into 3 once, 3 goes into 3 once. 3 goes into 3 once, and 3 goes into 3 once. Anything else we can simplify?
The 3 and the 12.
Excellent. 3 goes into 3 once, and 3 goes into 12.
4 times.
Excellent. So my only numerator is a
3